Hi, welcome all. Today we are going to discuss a topic in physics, that is matter. Okay. You all heard about the term matter. What is matter? Matter is something which occupies the space and it has mass and can be perceived by our senses. So it is called a matter. Matter means it occupies the space, it can be sensed over by senses and it has mass. Okay, can you give me some examples of matter in our daily life? Can you? Yeah, okay. I will tell you some of the examples. Okay, first one is oil, water, milk, ice. These are all the substance that relates to the term matter in our daily life. We all use this oil, water, milk, ice, etc. Okay, these are some of the examples of matter. Actually, this matter includes all the living and non-living things in the universe. Matter consists of all the living and non-living things in the universe. Okay, this matter is actually composed of small tiny particles. This matter composed of small tiny particles called molecules. Okay, this matter consists of composed of small tiny particles called molecules, and this molecules is composed of atoms, and these atoms are these molecules are freely exist in nature. They are independently available and freely exist in nature. These molecules, and molecules consist of atoms. They are freely exist in nature and they are independently available. Okay. According to the number of atoms in a molecules, we can classify these molecules as, according to the number of atoms present in the molecules, we can classify it as monoatomic molecule, okay, diatomic molecule and polyatomic molecule. Okay, according to the number of atoms present in the molecules, we can classify it as monoatomic molecules, diatomic molecules and polyatomic molecules. Okay, some examples of monoatomic molecules are helium, neon, argon, etc. are some of the examples of monoatomic molecules, because as the name indicates, it consists of only one single atom. That is why it is called as monoatomic molecules. And in case of a diatomic molecules, it consists of two atoms. This diatomic molecules consists of two atoms. That is why it is called the diatomic molecules. And examples of diatomic molecules are hydrogen, oxygen, etc. These are the some of the examples of diatomic molecules. And then third is polyatomic molecules. That is consists of more than 2 or 3 atoms. More than 2 or 3 atoms, it is called polyatomic molecules. And some of the examples of polyatomic molecules are water, carbon dioxide, ammonia, etc. These are some of the examples of polyatomic molecules. Okay, so according to the number of atoms present in the molecules, we can classify it as monoatomic, diatomic and polyatomic molecules. Okay. Okay, then next we can go for the characteristics of these molecules. Okay, next one is characteristics of these molecules. Okay, characteristics. Okay, there are 4 most important characteristics of a molecules. The first one is they are very small in size. They are very small in size. Okay, these molecules are of the size 10 raised to minus 10 meter. That is, they are very small, of 10 raised to minus 10 meter. Okay, they cannot be viewed by our normal eye. They can be seen with the help of a microscope. They cannot be perceived by our eye. They can be seen only with the help of a microscope, such a small tiny particle. Okay, it is of a size 10 raised to minus 10 meter. And second cara is, they have spaces in between them. They have spaces in between them. Okay, actually these molecules have small spaces in between them, small. This bubbles are called molecules. I am marking these bubbles as molecules. So they have, these molecules have small spaces between them. Okay, that space is called intermolecular space. Intermolecular space. Okay, this space is called intermolecular space, and this space, intermolecular space, the separation or the space between the molecules is very small in case of a liquids. Very small in case of a liquids, and it is little bit large in case of a liquid substance, and very large in case of a gaseous substance. Okay, this intermolecular space is very small in case of a solids. It is somewhat large compared to solids. In liquids, it is, the space is very, compared to solids, it is very large, and it is very large in case of a gaseous substance. The separation is very large, or the spaces between the molecules is very large. And the third cara is, they attract each other. They attract each other. That is, the molecules have a force of attraction between them. These two molecules and these two molecules, the molecules have a force of attraction between them, and this force is called intermolecular force. This force of attraction is called intermolecular force. If the space between the molecules is very small, then the intermolecular force is very large. If the space between the molecules is very large, then the intermolecular force decreases. That is, if space small, then force increases. If space is large, then this force decreases. Okay, and this force, intermolecular force, exists only when the separation between the molecules is 10 raised to minus 9 meter. That is, the space between the molecules is within 10 raised to 9 meter, then only this intermolecular force exists. Beyond this distance, this intermolecular force vanishes. That is, the separation, the space between the molecules is beyond 10 raised to minus 9 meter, then the force cannot exist. The force vanishes, completely vanishes. This force can exist only when the space between the molecules is within 10 raised to minus 9, or it is 10 raised to minus 9, at least 10 raised to minus 9 meter distance only. The separation is only within this distance, then only this force can exist. Otherwise, beyond this distance, the force cannot exist. Okay, so the space must be between this space, the intermolecular space, with this within 10 raised to minus 9 meter. Beyond that distance, the force vanishes. Okay, that is the third cara. And the last cara is, they are in constant motion. They are in constant motion. That is, these molecules actually not in at rest. They continuously move. Okay, they are not in at rest. These molecules are not in rest. They continuously move. And in case of a solids, as I said, the intermolecular space, that is the space between the molecules, the space between the molecules, this space and this space horizontally and vertically also. The spaces between the molecules is very small, so they cannot move anywhere freely. move about there, they can vibrate within the mean positions. They cannot move freely anywhere. In case of a solids, they cannot move anywhere. They can vibrate only within their mean positions. They can vibrate within only their positions. They cannot move anywhere. In case of a solids, because they are closely packed. Okay. And in case of a liquids, the space is somewhat large compared to solids. Okay. So they can move freely, but they can move freely only within the boundary of the vessel they are containing it. They cannot move outside. They can move only freely. They can move, but only within the boundary of the vessel they are containing it. They are holding it. The boundary of the vessel, within the boundary they can move freely, but beyond that they cannot move. Okay, so then in case of a liquid, the intermolecular space is somewhat large, so they can move freely within the boundary of the liquid. Okay, in case of a gas, they can move randomly everywhere they can move, everywhere in the space available to them. Okay, in case of a solids, they can vibrate only within the mean positions, and in case of a liquids, they can move within the boundary of the vessel they are holding it. And in case of a gas, they can move randomly everywhere in the space available to them. Okay, these are the four characteristics, four most important characteristics of a molecules, not matter, characteristics of molecules. Okay, these are the four characteristics of a molecules. Okay, next we can go for the states of matter. State of matter. What are the different states of matter? Can anyone say what are the different states of matter? Okay, there are mainly three types of states of matter. Okay, they are classified accordingly as solids, liquids and gas. Okay, these are the three states of matter. They are solids, liquids and gas. Okay, we can now study the molecular model of solid, liquid and gases. Okay, in case of a solid, as I said, in case of a solid, these molecules, okay, this bubbles marking in red is as molecules. Okay, these are the molecules. Okay, these molecules are, as I said, the interspace, the separation between the molecules is very less. As you can see in the figure, the intermolecular space available to them is very less. They are so tightly packed that they cannot move freely anywhere. Okay, here also molecules. It's not free. Everywhere it contains molecules. Okay, so they cannot move freely anywhere because they are closely packed. There is no space available to them move freely. They can move only about their mean positions. They can vibrate within their mean positions. They cannot move anywhere freely. Okay, these molecules are so tightly packed in case of a solids. Okay, and since, as I said earlier, this space is very small, so they have a strong force of attraction between them. Since the space is less, the force of attraction between these molecules is very, very large. They are a strong bond with each other, strong bonding with each other. The force of attraction is very, very large. Since the space is less, they have a very large force of attraction. And these solids, so because they are closely packed, they cannot move anywhere freely. So we can say that this solid have definite shape and definite volume. Since they cannot move, or these molecules cannot move anywhere freely, and they are so tightly packed, so the solid substance have a definite shape and a definite volume. Definite shape and definite volume. Okay, and As I said, the space is very less, so the force of attraction is very large. They cannot move anywhere freely. Okay, they are very rigid, closely packed, tightly packed. Okay, this is a molecular model of a solids. Then coming to the next one, liquid form. Coming to the liquid form, the molecules have little more spaces between them. Compared to solids, as you can see, there is a little bit space between the molecules. Okay, there is a little bit more spaces. Okay, these molecules, the spaces, they have small space between them. Compared to solids, they have spaces available between the molecules. So they can move freely. They can move freely. They can move freely within the boundary of the vessel. Within boundary of vessel, they are containing it. Okay. Since they can move within the boundary, and so they have no definite shape. They occur the shape in which the vessel they are holding it. They acquire the shape in which the vessel it is holding it. Say if we are holding the water in a round vessel, then they acquire the shape of a round. Okay, if it is a case of a cylindrical vessel, they acquire the shape of a cylindrical shape. Okay, so they have no definite shape, but they have a definite volume. Okay, they have no definite shape, but they have a definite volume. Okay, since there is a small space available between the molecules, the intermolecular space is large. Intermolecular space is large compared to solids. As you can see, the space is very small and the space is large compared to solids. So intermolecular space is large. Since the space is large, the force of attraction, intermolecular force becomes less. Intermolecular force becomes less. Okay, as you can see, the space between the molecules or the separation between the molecules increases, then automatically the force of attraction becomes less. Okay, now in case of a gas, okay, these molecules have very large space. Between the molecules, they have very large space. The intermolecular space between the intermolecular space or separation between the molecules is very large compared to solids and liquids. The intermolecular space is very large. Also, if the space is very large, then the intermolecular force becomes very weak. If the the space between them increases, then force decreases. That is inversely proportional. If space increases, then force decreases. So in gaseous substance, the space is very large. Space very large. So force becomes less. Force of attraction is less. Okay, so they occur. They can move everywhere in the space available to them. They can move randomly everywhere to the space available to them. So they have no definite shape and no definite volume. Steam, steam have any definite shape and volume? Okay, steam is in the gaseous form. Okay, ice. For example, we can say that ice is in a solid form. So it has a definite volume and a definite shape. When it is changed to water, ice when it is changed to water, does water have any definite shape? It contains the shape in which the water holding the vessel. Where we are holding the water, it is a round vessel, it is a cylindrical vessel, it occupies that shape. It has no definite shape, but it has definite volume. Okay, ice has definite shape and definite volume. When it is changed to water does not have any definite shape. It has only definite volume. Again, water, when it is changed to steam, gaseous form, steam Does steam have any definite shape and definite volume? No. The steam can flow anywhere to the space available to them. So steam or a gaseous form of substance does not have any definite shape and no definite volume. Neither definite shape, no definite volume. Okay. These are the three molecular models of solids, liquids and gaseous state substance. Okay, accordingly we can distinguish these three states of matter. Okay, we can distinguish them, these three states of matter. Okay, solids, liquids and gas. Okay, as I said, the solids have definite shape, definite volume. Okay, in case of a liquids, there is no definite shape, but it has definite volume. Okay, but coming to the gaseous substance, it has neither definite shape and no definite volume. Okay, as I said earlier, the intermolecular space is very less compared to in solids, and the intermolecular space is not very large. Intermolecular space is large in liquids when compared to solids. This intermolecular space, that is spacing between the molecules, is large when compared to solid state, and in case of a gaseous substance, this intermolecular space is very large. Okay, first, second and third part, force of intermolecular force, that is force of attraction. As I said, this, as the space increases, this force of attraction decreases. In case of a solids, the space is very less, so intermolecular force of attraction is very large. And in case of a liquids, it is somewhat weak. Not weak, it is small. Intermolecular force is small. Since the space is available to them is large, the intermolecular force is small. Then compared to liquid gaseous form, this intermolecular force is very weak. Why it is weak? Because the space is very large. So the intermolecular force becomes very weak. And fourth, what is fourth cara or fourth? They have they cannot move. They vibrate. They vibrate within their mean positions. They vibrate within the mean position. They cannot move anywhere freely. Okay, but in case of a liquids, they can move freely within the boundary of a vessel. Within the boundary of a vessel. And in case of a gaseous substance, randomly move freely anywhere, everywhere to the space available to them. Okay, they can move everywhere. And fifth one, since they have a definite shape and definite volume and the space is very small, the molecules are tightly packed, they are rigid form. They are in rigid form. They are in rigid form, and liquids and gases are not in rigid form. Okay, since they have definite shape, definite volume, they are very rigid. So, sixth one, they cannot flow. Solids cannot flow. Okay, is it ice can flow? No. But when it is changed to water, they can flow. If ice is changed to water, they can flow. So liquids can flow. Also, when it is converted to steam, when water is converted to steam, steam can flow. So gas can flow. Okay. So we can distinguish these three states of matter, solids, liquids and gases, according to their shape, intermolecular force, intermolecular space, and rigid they cannot flow and they cannot flow. According to this, we can classify the three states of matter as solids, liquids and gases. Okay, the next class we are going to study the change of states of matter, that is from solid state changing to liquid and from liquid to gas, that is change of state of matter. Okay, today I am winding it up. I hope all you understand this. Then thank you.